Okay, so we've got a jet of some kind, and it's going to be flying, let's going to say, pretty fast. And, okay, it's already bad drawing. I don't need to make it worse. We're going to say that its velocity is to the right, and its velocity to the right is 500 miles per hour. So it's going 500 miles per hour to the right. And what's it going to take time-wise to go 1,000 miles? Well, that's an easy problem because I picked easy numbers on purpose. Time equals distance over speed. So 1,000 divided by 500. That's miles are going to cancel, so you're going to get 2 hours. All right, not a big deal. But what happens if, while flying to the right, there is a wind to the right of 20 miles per hour? What does that do to the travel time? Does it remain 2 hours? Well, that changes things. That changes the velocity to the right. It is no longer going to be 500 because you've got 20 miles per hour helping you. So your new velocity is 520 miles per hour to the right. So now our new time is going to be 1,000 miles divided by our speed of 520. So when you put a bigger number on the bottom, that means your answer is going to be smaller. So our answer becomes, let's see here, where's my calculator? So 1,000 divided by 520. So it's going to be 1.92 hours. That should make sense. They call that a tailwind when you have a wind pushing on the tail of your plane. It's kind of helping you along. And I could easily also make up another problem that said, well, what if this 20-mile-an-hour wind, instead of blowing to the right, were blowing to the left? Well, then our velocity would no longer be 520. It would be 500 minus the 20, because now that's hurting our speed. So now our time is going to be our distance, which hasn't changed, over our speed, which is 480 miles per hour. So when you put a smaller number in the denominator, you get a bigger answer. And so if I go clear, I go 1,000 divided by 480. So I get 2.08. All right. So this is an example of a vector problem. Why is it a vector problem? Because not only do these numbers that we worked with matter, but also what matters is these directions. We had lefts and rights that we had to worry about, and they made a big difference to our answers. You know, with no wind, our answer was this. With a tailwind helping us out, our answer is this. With a headwind blowing against us, our answer was that. So when you do vector problems, you have to consider not only the speeds, but the directions.